This is lesson 12.1. Essential understanding, you can use two-way frequency tables to organize data and identify sample spaces to approximate probabilities. Number 1. The table below shows the number of students who passed their driving test, as well as whether they took a driver's education class to prepare. What effect, if any, does taking the driver's education have? So whatever I highlight, I would do underline it if you don't have a highlighter, just because it's important. So let's look at this table. Just a little bit of background. This number is the sum of this row. This number is the sum of this row. This number is the sum of this row. It's also technically the sum of this column right here. This number is the sum of these numbers, and this number is the sum of these numbers, because you're going to have to be filling in some parts on your chart on the homework. So anyways, let's look at the two different variables. Passed the class, failed the class, passed the driver's ed, or the test, and failed the driver's ed test, and then took the class, not took the class. So the question was, what effect, if any, does taking the driver's education have? So let's look at the people who actually passed the test and if they took the class or did not take the class. So let's look at people who passed and took the class. So that'd be 32 out of the 39 total kids that took the class. If we were to make that into a fraction, well, technically it's already a fraction, but if you were to put it in our calculator and press enter, it'd be a simplified fraction, or just do top divided by bottom times 100 to get that 82%. So 32 of the 39 students, or 82% of people, took the class and passed. Now let's look at people who passed but did not take the class. So did not take the class and passed, that's 18 out of 41 students. Top divided by bottom, 18 divided by 41 times 100, or 44% of people did not take the class and passed. So we can see that there's a big difference between 82 and 44. 82 is almost double the amount of kids. So almost double the amount of people who took the class passed versus not taking the class. So we can infer that you're more likely to pass the test if you take the class. A two-way frequency table or contingency table displays the frequencies of data in two different categories. Number 2. The two-way frequency table shows the data about student involvement in extracurricular activities at a local high school. What is the probability that a student chosen at random is a female who is not involved in extracurricular activities? Please make sure I would underline this with a straight underline and do like a squiggle underneath. So let's see. So it says, what is the probability that a student chosen at random is a female who is not involved in extracurricular activities? Well, let's look at this. We've got involved, not involved in activities, male, female. So let's find female, not involved. Female, not involved, well, that's 120. And then since it says the student is chosen at random, that's out of this number right here, which is the total number of students between male and female and involved and not involved in activities. If I do top number divided by bottom number, that simplifies to 10 43rds, and then multiplied by 100 is 23%. I would take either one on the homework or quiz or test. Number 3, the two-way frequency table below shows the number of male and female students by grade level on the prom committee. What is the probability that a member of the prom committee is a male who is a junior? So let's look at male, junior. Male, junior, that's 3. Now for the denominator, it says, what is the probability that a member of the prom committee, well, that means we're looking right here because it says the table below shows the number of male and female students by grade level on the prom committee. So all of these students are on the prom committee. So that's 3/12, simplified as a fraction is 1/4, multiplied by 100, that's 25%. So 25% of the prom committee is a male who is a junior. All right, the probability that an event will occur given that another event has already occurred is called a conditional probability. You can write the conditional probability of event B given that event A has already occurred as this. You read this as the probability of event B given event A. So here's how you do it. The probability of event B given, that's what that line means, event A. So I would take a moment and pause, write this stuff down with this arrow pointed to the word given. Or 4A. Respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What is the probability that a person selected at random is over 60 years old, given that the person had no opinion on the state bill? So there's two different conditions. This is called conditional probability. Now, conditions mean like certain things have to happen. Like, for example, if your parents say, hey, you can go and hang out with your friends this weekend on two conditions. One, that your room is clean, and two, that you have done all your homework. Well, here's the two conditions that we're looking at that have to happen. So let's look at the person selected at random is over 60 years old. So let's look at over 60. Given that the person had no opinion. So that's right here. So we're looking at this number right here, so 40. And this is just fancy notation for how to write it. I'm really just looking for the actual fraction or percent. So that's the numerator. Now here's a key word given. Whatever condition is after it, that's the total you're looking at. So I'm going to look at the total for the people who had no opinion on the state bill. Okay, no opinion, I'm going to look at this number here. That's the total for people who had no opinion. So I'm going to do 100. Simplifies as 2/5. 2/5 multiplied by 100 is 40%. Please feel free to pause and try 4B and 4C on your own. 4B, what is the probability that a randomly selected person is 30 to 45 years old, given that the person is in favor of the minimum wage bill? So two conditions, 30 to 45, in favor. For is another word or synonym for in favor. So we've got 200. And then we see this key word given. The condition after this word or in favor, that's the total we're looking at. So we're looking at the total number of people that are in favor for the bill. That's 780. 200 over 780 simplified as a fraction is 10/39, or multiplied by 100 is 26%. 4C. What is the probability that a randomly selected person is not 18 to 29, given that the person is in favor of the minimum wage bill? Well, not 18 to 29, that means we're not looking at this number. So all the people that are not 18 to 29 are these three numbers. So you can add all those up to get 470. Or you can take the total 780 divided by the 18 to 29-year-olds. We see this keyword given. That's going to tell us what our denominator is. So we're going to look at the total for people that are in favor of the minimum wage bill, which is 780. That simplified as a fraction is 47/78. Multiplied by 100 is 60%. Feel free to pause and try 5A and 5B on your own. A company has 150 sales representatives. 2 months after a sales seminar, the company vice president made the table of relative frequencies using sales results. What is the probability that someone who attended the seminar had an increase in sales? Well, there's two conditions. Somebody who attended the seminar and had an increase in sales, well, that's 0.48. By the way, these are percents. That 0.48 really means 48%. That 0.02 means 2%. So the probability of somebody who had an increase in sales given that they attended the seminar. So attended, increase, that's 0.48. For the denominator, we don't see the word given. But it says, what is the probability that someone who attended the seminar, so we're looking at people who actually attended the seminar, and the total for that is 0.8. If you were to make it into a decimal, it's 0.6 or 3/5, or you can have 60%. All are equivalent. 5B. What is the probability that a randomly selected sales representative did not attend the seminar, did not see an increase in sales? Did not attend the seminar, did not see an increase in sale. That's 0.18. And then it says so that's 0.18. And then for the denominator, we're looking at that a randomly selected sales representative who did not attend the seminar. So we're looking at people who did not attend the seminar. That's why it's 0.2 in the denominator. If you were to put that in your calculator, it'll be 9/10 or 0.9. And then 9/10 multiplied by 100 is 90%.